So we're going to relate the two halves of topic number 6 to each other, gravitation and uniform circular motion. And this is the reason why these two things are both part of topic 6. They come together when you look at objects orbiting each other in space. So the thing about an object in orbit, there's two things you can say about it. One is that, at least in IB physics, we're going to look at things which are in circular orbit. So if you're in a circular orbit, that's an example of uniform centripetal motion, which means our centripetal motion equations apply. And the other thing that we can say about it is what's causing it to move in a circle? It's gravitational force. And now that we know how to deal with gravity on bigger scales, we can actually relate these two things together. So on the left-hand side up here, we have the universal gravitational force formula. And on the right-hand side, we have the centripetal motion formula. And since in this example of an object in orbit, it's gravity that's causing the centripetal motion, these two F's, these two forces are identical to each other. So we can relate the equations with just a few little comments. On the left-hand side, there's two masses. And that's because the formula, the law of universal gravitation, is looking at the force between two objects. If I'm talking about an object in orbit, one of those things is the object at the center, the Earth in that previous picture, and the other thing is the moon, the object which is orbiting around the center. For the centripetal motion equation, we have one mass, and that's the mass of the object which is doing the circular motion. So in that case, in the example of the Earth and the moon, that would mean the mass of the moon. So we have the mass of the moon appearing in both of these equations, and we can cancel them out to make our relationship a little bit easier to deal with. So if we make that simplification and we set these two things equal to each other, we get this. And if you compare these equations to the physics data booklet, what you'll see is the equation on the left. That's our general equation for gravitational field strength, little g. And the equation on the right is the general equation for centripetal acceleration. So remember the m that we have left at this point, that's the mass of whatever object is causing the gravitational field. So in this case, it would be the mass of the Earth, for instance. So we could simplify this even further and say that acceleration is equal to gravitational field strength. And that's something actually we have known for a long time. We talk about the acceleration of objects in free fall all the way back in topic number 2. And it turns out that this is a generally true statement. It's just that G could be a lot of different things depending on what kind of gravity we're dealing with. If you're close to the surface of the Earth, G is 9.81, but it could be many different things, and you might have to calculate it using the law of universal gravitation. But we can say that in general, if an object is only being influenced by gravity, then its acceleration is going to be equal to its gravitational field strength. And if we're looking at circular motion, then we can do some additional calculations using this relationship, because we know for an object in circular motion, its acceleration is also equal to v squared over r.